Good evening, Algebra 2. Today we are going to talk about powers and roots of negative numbers. And we all know negative numbers behave differently than positive numbers do. So let's investigate a little bit here. First things first, we have integer powers of negative numbers. And yes, I would like you to write this down. I know it's a lot, but it's important. It says you can calculate positive integer powers of negative numbers using repeated multiplication. Therefore, if I have negative 8 to the first power, well, we just have one of them, so that's negative 8. If I have negative 8 squared, now notice I'm taking this negative 8 all to the second power, so the negatives along with the 8, so we have 2 of each. So therefore we'd have a negative times a negative, giving us a positive, and 8 times 8 is 64, so then we end up with a positive 64. If I have negative 8 to the third power, I'd have negative 8 times negative 8, that result would be a positive, then times another negative 8 would flip it back to being a negative number, so we get negative 512 here. If I take 4 of them, then I have 4 negatives. I have negative times a negative, which is a positive, and then negative times another negative makes this result a positive. So then these two positive numbers multiplied together gives us a positive 4,096. Notice that these integer powers alternate between positive and negative numbers. The even exponents produce positive numbers, and the odd exponents produce negative numbers. Okay, and this is something we've kind of seen throughout the last couple chapters, and that's always going to be the way that it is. So if you have an odd number, you get a negative result. If you have an even number, you get a positive result. Now we can extend this idea to having negative exponents, which makes a rational result here. So the same is true if 0 and negative powers of negative 8 are considered, since negative 8 to the negative nth power is the reciprocal of negative 8 to the positive nth power. So let's take a look at what's going on here. I have negative 8 to the 0. We know anything to the 0 power is 1. Okay. Negative 8 to the negative first power, well, we all know what all that does is negative exponents move our stuff downstairs. So it's negative 8 to the first. So negative 8 to the first power is just 8 here. And the negative just popped out front. This is the same thing as 1 over negative 8. So that's negative 1/8 is our actual result there. Then if I have negative 8 to the negative second power, that would be 1 over negative 8 squared. Okay, that's equivalent here. We know negative 8 squared is just 64, so we would just have 1 over 64, which is exactly what we have over here. Following this trend, this is an odd number. It would just be 1, hang on, I'm running out of room down here. It's a really long equal sign. 1 over negative 8 to the positive third power. We know negative 8 to the third is a negative 512. So we get negative 1 over 512. And then negative 8 to the negative fourth power is 1 over negative 8 to the fourth power. Take negative 8 to the fourth power, we get a positive 496. So notice the same result here. We have 2 evens and 2 odds, and these were positive numbers here for our evens, and these were negative numbers here for our odds. Okay? And since 0 is technically, we think of it as a positive, we got a positive number here. Or we think of 0 as even, so therefore we got a positive number. Okay, integer powers of negative numbers satisfy the order of operations. So negative 8 to the fourth power is negative 4,096. And you might be thinking, that is exactly opposite of what you just said. But here, notice I don't have parentheses here. So because the power is calculated on the 8 before taking the opposite. So we do 8 to the fourth power and then throw a negative out front is the way that this one works. Okay, so we end up with negative 4,096. Okay, however, as shown before, now if I put parentheses around this whole thing, then that's saying take 4 negatives as well, and your result will be a positive. Therefore, when I have negative 8 to the fourth power without parentheses, that is not equal to negative 8 to the fourth power with parentheses. These are very different things. This one's going to be negative, and this one's going to be positive. All right, finally, we have an example here. It says write as a power. So we have a negative 8 to the fourth and negative 8 to the negative third power. Now notice, I'm just going to rewrite this here. Negative 8 to the fourth times negative 8 to the negative third power. We can use our exponent rules here because notice we have the exact same basis here. It's just as if these were both x's and we had x to the fourth times x to the negative third. Well, what would you do here? You add your exponents. So that's the same idea We have 8s though, so we'll go back over here. But that's the same idea as what we're doing here. So it becomes one base, so it's just negative 8. And then we have to do 4 plus a negative 3, which is really just 4 minus 3, so that would be 1. So it's negative 8 to the first power, and since they want it as a power, I guess we better leave that exponent of negative 8 to the first. But we do know that that is equivalent to just negative 8. So I guess either answer would be correct, but they want it as a power, so this one is preferred. Okay, I know we got a lot of writing in this one, but we have another definition, and it says when x is a negative and n is an odd integer bigger than 2, then the nth root of x stands for the real nth root of x. Okay, for instance, we had the cube root of negative 8. Before, we were not allowed to have negatives underneath this root, but that was back when they were only square roots. So now when we have a cube root, well, is there something we can multiply by itself 3 times to get us to negative 8? Well, yeah, it would be negative 2, because negative 2, this says negative 2 cubed, but I'm just going to write it out, times negative 2 times negative 2. Does that equal negative 8? Well, negative times a negative, this result is positive. Then a positive from here times another negative does result in a negative number. And then 2 times 2 times 2 is 8. So we do end up getting negative 8. So yeah, it does work out. So now that I have cube roots under here, then I'm allowed to have a negative. If it's a square root, or a 4th root, or a 6th root, or any even number, this won't work. It has to be for odds. So odd, let's say, sorry, let's go. Odd roots only. So odd roots only. Okay? So negatives can happen here, but only for odds. Why is this significant? Well, remember the square, remember there's an invisible 2 here. The square root of negative 8 was undefined in the real number system because no negative times itself will produce another negative number. Thus, we introduced the imaginary numbers. Okay, so I guess you can still have imaginaries here, but these are not real. So we can't say it has a real solution, it has an imaginary solution. But if we take the cube root of negative 8, it is possible in the real number system because the product of 3 negative numbers is a negative number. So we can result with this negative 8 with the product of 3 negative numbers. Okay? Very important. Make sure you write this down and understand it. If you don't understand it, ask me to explain it a little further tomorrow and I can do so. Okay, example 3. We're simplifying the cube root of negative 2,000. Yikes. So cube root of negative 2,000. So this is just like before when we're actually breaking this negative 2,000 down. Let's check it first because it itself might be a cube root. So let's get our calculators out. I hope you get yours as well. So 3, math, and we're choosing, remember, option number 5 here. And then we put in negative 2,000. And let's see what we get. Okay, we get a decimal, so it doesn't work out evenly. So we actually have to do the prime factorization again. Hopefully you remember how to do this. Prime factorization. Because we've been doing it a little bit here. So remember this is the upside down division. So we take negative 2,000. Well, I guess we don't really need to write the negative. We can just put 2,000. So let's do this. All right. And we put an upside down division, and the first prime we can factor out of this guy. Remember our primes are 2, 3, 5, 7, 11, etc. 2 will totally work, so let's do 2. So 2 divided by, or excuse me, 2,000 divided by 2 gives you 1,000. And we divide that. Oh, 2 will still work, so let's keep working with 2. So 1,000 divided by 2 is 500. 500 divided by 2 is 250. 250 divided by 2, that'll work. It's going to be 125. 125 divided by 2, nah, that's not going to work. We're done with even numbers. Is it divisible by 3? I don't know. Let's find out. So 3 is the next one we want to try. 2 is done. 125 divided by 3. I don't think this is going to work, but let's just double check. So 125 divided by 3 Nope. All right, so we got to move on. 3 is not going to work for us, so 3 is gone too. 5 is next, so 5, yep, this is going to be divisible by 5. 125 divided by 5 is 25. Looks like we can keep going with 5s here, so then 5 goes into 25 5 times. Okay, we got a long factor tree here, but we can totally make this work. Now notice we're taking the cube root here, so we want to focus on pairs of 3. I guess I wouldn't make it a pair then, it'd be groups of 3. So we have 3 5s and we have 3 2s, and then we have 1 extra 2. So I'm going to group these as such. So I have 2 cubed, and then I have 5 cubed. Those are going to sit next to each other. And then this last lonely little 2, I'm going to segregate him by himself because he's actually going to have to stay underneath the square root. All right. So I'm going to go ahead and rewrite negative 2,000 as negative, and then we'll put that negative with the 2. So negative 2 cubed. I guess they'd all be negative numbers. No, that wouldn't work. We'll just put the negative with the 2. Whoops. Sorry. Oh, yikes. Sorry. Okay, so negative 2 cubed. Well, that negative is kind of by itself here. We'll put it with a 2, just to make it a little more clear. Times 5 cubed, right, times negative, or just, excuse me, times 2. Okay, so this is this thing. I just decided to put the negative in with the 2. You can put it with any one of these. I would suggest putting it with a cube root so we can actually pull it out of here. But I just chose to put it with the 2, and I can do that. I would put it with a 5. I wouldn't put it with this guy because that means it's going to stay underneath, and we want it to come out. Okay, so the cube root, now we can break these all down. So negative 2, excuse me, the cube root of negative 2 cubed. And then we can separately write the cube root of 5 cubed. And then separately we would have the cube root of 2. Okay, cubes and cube roots are canceling each other out right here. So we have negative 2 times, guess what, these are going to cancel as well, times 5 times, can I cancel this last one out here? No way, because there's no cubed out here to cancel it with. So I still have the cube root of 2 hanging out over here. One last step till we're all simplified. I would have negative 2 times 5, which is negative 10, and then I just have the cube root of 2. And that's it. That's as far as we can go. So we are done. And you might be thinking, wow, that was simple. I don't think so. The process maybe was not so simple, but this is actually simpler than saying the cube root of negative 2,000. I was able to pull the negative out, I was able to pull a 10 out, and the 2 was the only thing that was left over. All right, that's it for today. So hopefully you got a little bit of new skills there, and we will practice them tomorrow during class. See you then.